Hello and welcome to my talk about calling coroutines from Swift and helping yourself with KMP-NativeCoroutines, which is actually the library which won the Kotlin grant 2 days ago and was mentioned on the morning Ekaterina talk yesterday. So pretty exciting stuff. I'm Aleksander Jaworski. I'm an Android developer at Football.co. I've been playing around with Kotlin Multiplatform for over 4 years now, when it was still experimental. I also have a blog which focuses on Kotlin Multiplatform and testing, so an obligatory self-blog. You can also reach me on Twitter if you have any questions. And yeah, what is Kotlin Multiplatform? Well, you probably know that. I won't go into the details, just repeat what was in the previous decks. But a better question might be, how do I call Kotlin from Swift? Well, that's pretty easy, because Kotlin generates the code you can call in Swift. So this function will turn into this function, and you can call it like this. So seems pretty normal, right? Pretty straightforward. But what about coroutines? Well, things are getting a lot harder, because having this function, which is suspending, we are generating this one, which is more complicated. It has a lambda, which takes in an error parameter. So OK, some confusion there. And you call it like this. OK, not so bad, but there are some issues with this. How can I cancel this? What about changing threads? Is it possible? And exception handling? Well, might be, because there is an error parameter, right? In today's agenda, I'll be going over 3 ways of how we can call coroutines from Swift. First will be the default, the official one, where we call suspend and flows directly as they will compiled or generated. The second approach will be using manually created coroutine wrappers. And the third one will be KMP-NativeCoroutines, which will be the crème de la crème of the talk. And also, I'll touch on exception handling and cancellation in Swift. And if there's time, I'll go over Swift UI integration. But that depends how nervous I get and how much I will forget in the talk. And yeah, why am I talking about this? First of all, it's important. Like most of the stuff we are talking over in this conference. But besides that, in order to use Kotlin Multiplatform, we have to convince the iOS guys that it's fine, it's OK, it isn't problematic at all. And one of the biggest issues I found with Kotlin Multiplatform is the place where Kotlin and Swift meets. So this talk will address the issues with coroutines and how we can call them and make it easier on iOS developers. The app which is used for the presentation is uses the KMP starter, which basically downloads something from the API, saves this to the database. There will be the 3 ways of calling coroutines. The repository is available here. You can check it out in your free time. There will be also a link to the deck at the end, so you'll have the full presentation with all the links. So what we'll be calling? First, a normal function, which just returns a job. Second would be the suspending function, which actually returns a value. And third one will be a data stream in the form of a state flow. You could notice that the view model uses a superclass, which has access to a view model scope, and a clear function, which just cancels all children coroutines. So yeah, starting with the ordinary functions will be the easiest one, because it's just a normal function. You just need a scope for it. You call the coroutine, and in Swift, you just call the function. It's OK, but there are some drawbacks, because it's mostly used for fire and forget functions, where you actually can't get any data back from it. And also, we usually use it to modify internal states, like modifying the database, modifying a state flow, which we then collect in the UI. And also, it requires us to have a coroutine scope available in order to launch it from Kotlin. So for suspending functions, we're going through the 3 ways: default generated framework, manual adapter, and also the KMP-NativeCoroutines plugin. So why do we need suspending functions? Well, we, for example, want to know when it will complete what's the return value, and we also want the ability to cancel it, right? Because we don't want to waste the user's resources. And the function we'll call is this one. I won't go into the details. It returns true or false, depending on if it goes well or not. And yeah, the generated function looks like this. We call it from Swift, passing in a lambda, which takes in two parameters. One is for the return value, and the second one is for the error. OK. And the print, it looks a little bit worse because we have an optional value here. So this means that any suspending function which is called will return an optional value, or it will return an error. So we don't have the luxury of having non-null return values here. And also, we can't cancel it. And also, there is no error handling. You might think so because there is an error parameter there. But actually, this only concerns the cancellation exception. So if any other exception happens, the iOS app will just crash. So the user experience, not so good, to be honest. But we can do better. We can create manually a wrapper, which is basically a class that has a scope, and the suspending lambda, which will call the repository, the API, whatever you want. But it requires us to have an additional class on the iOS side. So we can't actually use this directly from Swift as it is. We have to create a class which will return the suspending adapter or wrapper. And then we call this wrapper using the subscribe function, which takes in two lambdas, on success and on throw. With this approach, we have a lot better error handling. The API is much nicer. We don't have any optional or nullable values because we just have the unsuccess lambda, which is called on success. But it requires a lot of additional boilerplate. However, you can integrate it with native solutions like Combine. So the developer experience is a lot nicer. The API is better. There's error handling. We can cancel it. But the shining gem is KMP-NativeCoroutine, which basically alleviates all of the issues we were having before. So to have a suspending function in Swift, you just add the native coroutines annotation, and that's it. If you have the plugin enabled in the Gradle, it should just work as is. So yeah, there's no boilerplate, unless you count the one annotation, but I don't think that's boilerplate. There are no optional values, and there are dedicated Swift packages which you can use on your iOS app. So if you use Rx Swift, great. Combine, great. Async await, it will also work. So you have the ability to give the Swift or iOS developers a way to use it like they would call a native implementation. That's hence the name, KMP-NativeCoroutines. So you can see that there is a do catch around the call because we have to handle errors, but I'll go more into depth later. And also, we have the ability to automatically cancel it. So if the UI deems it that we don't need this call, it just can be canceled automatically. We don't have to worry about it. So I have shown you one way of doing it. It's the async function, which looks like this. It requires us a do catch, but there is another way. It's called the async result, which actually returns us an enum for the success case and for the failure case. So it might be nicer for some people. There is another way. If you don't care about the errors, you just want the value back if it succeeds and ignore the error, you can use an if case, and it'll do that. So the developer experience is much, much better. There's no boilerplate. Almost everything is handled for us. We have integrations with native libraries without having to implement anything ourselves. And what about flow data streams? Because, yeah, cool. We can call suspend functions, but we also need to have a reactive UI because that's the latest phase, right? So for flows, we'll go through the three ways, but I'll just glance over the first two ones because, yeah, it has limitation, it has boilerplate, so it's not that interesting. To use flows in the original, official way, you have to implement a Kotlin interface in Swift, which isn't that nice. To call it, you use this. OK, it works, but it's not nice. Flow adapters, even more boilerplate. I won't go into the details, but you can see there's a lot of code. You have to repeat a lot of stuff. But Kotlin or KMP native coroutines, you just slap on the annotation, and it just works. In this case, we have a view state, which we will use to populate our UI. And yeah, as you can see, we also use a Swift function called async sequence. So the same as suspend. You just call what you want to call, put it into the function, and you will have a sequence. We don't have to do any casting, because I didn't mention it before, but the previous two solutions required you to cast the value at the collection place, because when Kotlin Multiplatform compiles, it loses any information about the generics. And because flows are generic, the return values are lost. This library fixes this issue. We don't have to do any casting. It works as is. The API we have in Kotlin, so the contract, is the same as we use in Swift. And as you can see, we iterate over the sequence. Any new value updates the state. And also, we have some error handling and automatic cancellation. So the best of both worlds. And one thing to note, collection happens on the default dispatcher. You have to manually use main actor to have it on the main thread, but I'll go into that more in the details later. So we can control the scope, but this requires us to actually specify the scope from Kotlin, which might not be actually a bad thing, because it gives you more control. You can specify on which thread or dispatcher the suspension happens. But keep in mind that we can use the main scope for flows. However, this scope, which is annotated here, will be only used on the Kotlin side. So when we are collecting the data, only the collection happens on the main thread. Once it's sent back to Swift, then Swift controls on which scope this is happening. So we still have to use main actor for cases where we will update some Swift UI state, which is used in the UI. OK, so to show cancellations and exceptions, I have a playground screen here, which is basically a screen where there is an incrementation happening at the top, which can be canceled with this button. We have a button which just generates a result. So it's 1, 2, 3, and then an error happens, which you can retry it. There's a function to throw exceptions. And there is an open in the new screen button, which will be used in the automatic cancellation section, because we will get rid of the screen, so we want to automatically clean up after it. So for exception handlings, the suspending function will have a delay of 1 second, and then an exception will be thrown. And yeah, we call it like before, but with some additional print statements. And the output is as follows. We have a start. After 1 second, there's a failure, and we see that it's a Kotlin exception, an illegal state exception. We can also use the variant with the enums. The result does not change. For flows, we also have just a flow which emits 3 numbers, 0, 1, 2, and then exception is thrown. So yeah, as before, you do a do catch, await the sequence, and what happens? We have 0, 1, 2, and then the Kotlin illegal exceptions. So yeah, as expected, we have to do the do catches. If we want to ignore the catching, we don't care about the error, we can mark the function as throws, and then in the calling place, we can use try question mark, await, and then the error will not be shown. OK, so the exception handling is a little bit awkward. Not sure if it can be used for any conditions, retries, etc. It would be just better to return an enum, a sealed class, whatever a representation of an error might be, maybe even a null. So for cancellations, we will again use the number flow, which produces a value and just increments it every 1 second. And additionally, there are logs for every time the number increases and when the flow stops completing. So this way, we will know from Swift if the flow is being listened to or if it has been completed. So as you can see, the manual cancellation is pretty similar to what we had in Kotlin. We can just launch a coroutine have a job and then cancel the job. In Swift, it's just a task. So yeah, we assign the task, and then we can cancel it and null it out, and the flow will be stopped. And you can see that there is an error, but it's maybe not an error. It's just the onCompletion log tells us that it was canceled. For automatic cancellations, we will use the nested screen. So if we open in a new screen, it will be a navigation sub-screen, I guess. And if you close it, yeah, it would be best to stop listening to any flows, cancel any outstanding suspensions. And in this case, if you use the async keyword with async await, and you have the view, if you launch it using the helper task or onAppear task, if you await on it here, then it will be automatically closed. To point it out, I've added some logs when the class is initialized and deinitialized. So this is the place in the memory of the class. And yeah, when it's deinitialized, all of the collections are canceled. So we don't have to worry about cleaning anything up ourselves. It's just done automatically for us. So yeah, why do we bother with cancellations? Well, we want to free up resources. We don't want to waste the user's network or disk space, whatever. If it's avoidable and necessary, just do it. And also, we can avoid memory leaks. So that's also nice. No one wants a laggy app which just stops, grinds to a halt after 5 minutes of use. And the Swift UI. It seems that I've speedrun from my deck, so we have time for it. So the Swift integration, I'll go a little bit more in depth because it might be interesting for some. Even though Kotlin Multiplatform has Compose support, some of the iOS developers, I think, will still like to use Swift UI on their site. So maybe it might be worth for all the KMP developers here. So yeah, we use async await as in the presentation. We use something called observable object, a published annotation, and a state object. So again, the same screen, are you familiar with it? But we'll focus on the number flow. So yeah, this is the flow. It increases every 1 second. And yeah, on the Swift side, we have something which is called observable object. It works pretty similar to what we have with view models. Basically, the thing, the presentation layer class has to be a subclass of this one. And this will let Swift UI or whatever UI framework there is, let them know that, hey, this will be updated. You should update the UI. And if you to actually have a property be listened to in the UI, we have a published property, which is similar to what if we would have a state flow or just a state in Compose. So we listen to the sequence. We update the number in the sequence, so new numbers, update the UI. We have a catch here. And for the view, it's just a Swift UI. We create the class using the state object annotation. We have the view, and we just use the property. So nothing surprising. Seems pretty good. No boilerplate, and it just works. There's nothing, no issues with it. And yeah, as a bonus, there is a library from the same author called view model, which basically does the same thing I just showed you. It's a wrapper for KMP-NativeCoroutines, but additionally, it generates the boilerplate in the case of the observable objects. So here's a list of annotations which you use in Kotlin, and then the generated code will be either an observable object, state object, whatever you want. So basically, it reduces some steps in boilerplate creation on the Swift side. However, I found some issues with it when trying to test the common view models, so I haven't had the chance to try it out more yet. But KMP-NativeCoroutines works. This is a bonus. You can try it out for yourself. Maybe you'll be happy with it. And to summarize, what we've learned, or at least I hope I've gone through this, we learned how to call suspend functions or collect throws in Swift using different approaches, and figured out that KMP-NativeCoroutines is actually the best one. and how Kotlin exceptions can affect the iOS app. So if they're not handled, they can crash the app, unfortunately. So we need to be wary of that. And why cancellation is important, and how KMP-NativeCoroutines makes it a breeze to use from Swift, because it can be just cleaned up automatically. We don't have to worry about it. And yeah, I've shown how to integrate it with Swift UI. Here are some learning resources. If you'd like to dive deeper into Kotlin Multiplatform, I can recommend John O'Reilly's blog and all of his repositories. He has a lot of great stuff. There's a repository, People in Space, which basically has like a Kotlin Multiplatform app, which is mobile, like Android, iOS, desktop, web, all of the stuff that's possible, it's there. Also, TouchLab is a great contributor to the KMM ecosystem as a whole. They've started working with it long before I have. And also Marco Gomerio, which has some posts about using KMP from an iOS developer perspective. There's also a self-blog from my blog. If you're interested in testing or Kotlin Multiplatform as a whole, go ahead and see what's up. My final message is KMP-NativeCoroutines makes the developer's life more easy and a lot more fun to use. Yeah. So if you're interested in the slides, here is the deck. This one is for the async, so async await support. But I have another presentation, so which you can have here. It uses the combine. So if your iOS developer team likes to use combine, they don't want async await, or they're migrating to it, this can be used in place. And yeah, these are the resources, and that would be it, I guess. So.